Today we are going to look at the law of cosines. Okay, so previously we looked at the law of sines. The law of sines is something that you always use when you have an opposite pair. Okay, so the law of cosines is a different rule that you can use that you would not have an opposite pair on. Okay, so you're going to use the law of sines anytime you have the opposite pair. Law of cosines, basically, if you don't. Okay, now I will warn you, I think the law of sines is easier than the law of cosines. So if at all possible, stick with the law of sines. Okay, but again, you can only do that if you have the opposite pair. All right, so let's take a look at this. So we're going to say, here's my triangle ABC. All right, which means that this is opposite side A, this is opposite side B, this is opposite side C. All right, now for the last few things that we've done, I've been trying to show you like the derivation, where these different rules come from. The law of cosines is a little bit more complicated. So for this one, I'm just going to show you what the rule is and ask you to kind of take my word for it. If you would like to, at some point, go over where this thing came from, I'm more than happy to do that with you. But I just think it'll be making your life a little bit easier if I just kind of give you the rule. Okay, so here's what the rule is. It's going to feel a lot like the Pythagorean theorem. Okay, so the Pythagorean theorem says a squared plus b squared equals c squared. Okay, it's got notes of that to it, but you can only use the Pythagorean theorem with right triangles. And in this unit, we're looking at non-right triangles. Okay, so that's what makes it a little bit different. So here's what this law of cosine says. Law of cosine says that if you want to find this side over here, okay, so c squared is equal to a squared plus b squared. That's the part that feels like a Pythagorean theorem. Okay, but then it's minus 2 times a times b times the cosine of angle C. Okay, so everything in here is a side length except this angle at the end. Okay, and notice that this side and this angle are across from each other. So these two things on the outside are across from each other. Which one's A and B honestly really doesn't matter. But what does matter is which one is C and which one is the angle opposite it. Okay, because that has to be locked in. All right, now we did this with A, B, and C. It doesn't matter which particular sides that you're looking at. You could similarly say that A squared is equal to C squared plus B squared minus 2 times C times B times the cosine of A. Okay, that's the same thing. The Pythagorean theorem doesn't work that way. Pythagorean theorem is not interchangeable, but the law of cosines it is. And then similarly, I could say that B squared is equal to A squared plus C squared minus 2AC times the cosine of B. All right, so you're going to notice that these letters are always the same, and these guys always have to be an opposite pair. All right, so let's take a look at this example. So we are going to solve this triangle. Solving the triangle, as a reminder, means that I need to find every side and every angle. So that means I'm going to need to figure out this guy, and I'm going to need to figure out these guys here. Okay, so let's take a look at this. So we want to use the law of cosines, and a good trigger to kind of see to know that you can use the law of cosines is when you have two sides and the angle between. Okay, so that's kind of similar to when we did area of triangles. So you have to have the two sides and the angle between. Same thing, the law of cosines, two sides and the angle between them. Okay, so that is going to let us find side A over here. All right, so let's run through this. How are we going to find side A? So to find side A, right, I know that A squared, that's my unknown. Okay, and I know that I want the A here because it's opposite the angle that I know. Right? Remember we said the two things at the ends have to be an angle and the side opposite it. So I know I start with A squared because I know the 116. Okay, so A squared is going to equal my two sides squared added together. Okay, and then minus 2 times A, which is 28, times B, which is 27, times the cosine of the angle across from this guy. So the angle across from side A. So the cosine of 116. All right. So now we have this lovely equation that we're going to solve. So the first thing I'm going to do is do 28 squared, which is 784. And then 27 squared is 729. I'm just throwing this in my calculator. All right, and then I'm going to do 2 times 28 times 27. So 2 times 28 times 27 is 1512 times the cosine of this 116. All right, now here is the most commonly messed up part when people do this. Okay, every year I have people do this. They'll add these two numbers together and then subtract the 1512 and attach that to the cosine of 16. You can't do that. Don't forget about order of operations. This is multiplication here, right? This is times the cosine. So you can't combine this 1512 with these two numbers. It doesn't work. Okay, you can add these guys together. So I can add the 784 and the 729 together. That's 1513. Okay, that's okay. But then what a lot of people will try to do is they'll say, oh, well, 1513 minus 1512, that's 1. So this equals 1 cosine of 16. No, you can't do that. Okay, it doesn't work that way. Now, for this particular problem, because this is all number, I can just throw this in my calculator, right? So I'm doing the 1513 minus 1512 times the cosine of 116. All right, so that's going to give me that a squared equals 2175, oops, 0.8. Put my decimal in the wrong spot. That doesn't go there. All right, and then to get a by itself, I'm just going to square root both sides. So I'm taking the square root of that answer, which is 46.6. Okay, and now we know that side length. All right, really quick, if we had done the other thing, if we'd subtracted these guys first and gotten 1, then we would have cosine of 116, right? And my answer would have been negative 0.43, right? Which totally doesn't make sense. When you try to square root that, you're going to get an error. Okay, so you should notice if you're paying attention that your answers don't make sense if you do it that way. All right, but please keep that in mind. You can't subtract these two numbers and then deal with the cosine. You've got to multiply this first and then subtract that answer. All right, great. So now we know that this guy is 46.6. Lovely. All right, so we've got that side length. Now we need to solve our right triangle. We're not done yet, right? We have to find all the sides and angles. So now we have all the sides. We have one angle. So I need to get another angle. Now you could, from here, use another law of cosines, right? I could use, say, that the sine of C, right? I'd want to look for sine of C. So I could do this squared plus these two squared minus 2 times these two times the cosine of C and then solve from there. Okay, but I now have an opposite pair, and the law of sines is usually easier than doing the law of cosines. So I'm actually going to switch over and do a law of sines instead. Okay, so I'm going to say that the sine of 116 divided by the 46.6, okay, and I know I have to use those because those are my opposite pair, remember. That's going to equal to, oh, I'll use this guy. So the sine of angle C divided by 28. Okay, and then I'm going to go ahead and solve this. Cross multiplying is usually easiest for people. So I'm going to cross multiply here. So 28 times the sine of 116 is 25.2-ish. Right, and that's going to equal that 46.6 times the sine of C. Divide both sides to get my sine by itself. So I'm going to divide that by 46.6. That's 0.54. All right, and then I'll use my arc sine to figure out that my angle is 32.7 degrees. Right. So there we go. All right, great. So now I know that this angle right here is 32.7 degrees. Great. We got one more thing to find, which is angle B. Now, you could use another law of sines and say, okay, well, this divided by that gets you this ratio here. But at this point, that would be extra work. Okay, you want to go with the easiest thing possible, right? Well, the easiest thing possible, if I know two angles in a triangle, is that they all add up to 180. So to find this last angle, I'm just going to do 180 degrees minus 116 minus that 32.7, right? And that's going to give me angle B, right? So the measure of angle B. So on my handy dandy calculator, 180 minus 116 minus 32.7 That's going to be a 31.3 degree angle. So that is my last missing piece. And now we've solved our triangle. Okay. Now, one quick note. Again, this rule of, oops, cosines. That's a typo. Okay. You can only use the law of cosines to find acute angles. It will not work with obtuse angles. Okay. So let's talk about, again, really quick, why is that? Okay. The reason why is because when you look at different angles, right? Some angles have the same cosines as others, okay? So if I look at, say, the cosine of a 30-degree angle, okay, the cosine of a 30-degree angle is going to be the same as, say, the cosine of, oh, let's see. Wow, I just totally lost where my brain was going. Yeah, there we go, 390. That's the same. Okay, so these both have the same cosine. So if you know what your angle is and you're trying to backtrack, so I'm sorry, if you know what your cosine is and you're trying to backtrack and figure out what the angle is, if your angle was supposed to be 390, your calculator doesn't know that. It's always going to tell you the 30. Okay, so the law of cosines, you've got this thing called an ambiguous case where your calculator won't be able to tell you which angle it is. It's always going to assume it's the smallest one. Okay, so you need to make sure that you're just aware of that when you're using the law of cosines. So like in this case, trying to figure out this 116 angle, that's an obtuse angle. So using the law of cosines to figure out the measure of that angle, that wouldn't have gone well for us. Okay, so just be aware of that as you look at these.